Today in Math 30-1, we're going to look at topic 3.2, the remainder theorem. Now, first thing we're going to do is we're going to review how to do long division. As you can see, we have 12 divided into 327. First thing you ask is, how many times can 12 go into 32? Well, you can go into there twice, so put a 2 on the top. Now 2 times 12 will give me 24. When I take that and subtract it, I'm going to get 8. Now I have to bring down the 7. And now you have to ask, how many times does 12 go into 87? And that's going to go in there 7 times. And that'll be 84. So when you subtract now, you get a remainder of 3. 3 is the remainder. 27 is the quotient. 12 is the divisor. Now with long division, we're going to follow the same process. X plus 3 divided into x squared plus 7x plus 17. The x goes into the x squared. That's the first thing. Now x times x is x squared, so we're going to multiply it by an x. First of all, that tells us that 327 cannot be divided by 12 evenly. There's the x we're talking about. X times x is x squared. That gets rid of the first term, plus 3x. So when you subtract, you're left with 4x. Bring down the 17. Now x can go into 4x 4 times, so we're going to put plus 4 on the top. 4 times x is 4x. 4 times 3 is 12. Subtract, and I'm going to get 5. 5 again is my remainder. This also tells me that x plus 3 cannot be divided into x squared plus 7x plus 12 evenly. There we go. If a polynomial cannot or can be divided by a divisor evenly, the remainder will be 0. And this also means if a divisor will be a factor of the polynomial, if it can be divided into it evenly. Now we're going to do this using short division. Instead of x squared plus 7x plus 17, we're just going to use the coefficients, 1, 7, and 17. We're dividing it by x plus 3, so the root is negative 3. Put the negative 3 to the side. You bring the 1 down to the bottom, the first coefficient. Now you have to go negative 3 times 1 to get negative 3 and put that under the 7. And you add that column to get 4. Now you multiply again. Negative 3 times 4, and you're going to get negative 12. Put that under the 17. Add that column, and you're going to get 5. Notice that we got the same answer above. 5 being our remainder. The last column is your remainder. The next columns are going to be your 1's and your x's. So there's your x plus 4, your quotient. Example 1. Let's divide 5x cubed minus 13x squared plus 10x minus 9 by x minus 2 using short division. And the way we're going to write it is the polynomial divided by the divisor is going to equal the quotient plus the remainder over the divisor. And what that means, for instance, is if we went 9 divided by 2, we'd write it as 4 as the quotient, and 1 over 2 is the remainder. So here we go. Bring down the 5 first. 5 times 2 is 10. Write that under the 13. Add that column to get negative 3. Now start again. 2 times negative 3 is negative 6. Put that under the 10. Add it up to get 4. 2 times 4 is 8, and I get negative 1. There's my remainder, my 1's, my x's, my x squareds. So now you can say that it's going to be 5x squared minus 3x plus 4 minus 1 over x plus 2. You can complete your turn on your own. In example 2, how to apply division to solve a problem. The volume of a box is v of x is equal to x cubed plus 7x squared plus 14x plus 8. What are the possible dimensions of the box in terms of x if the height h in centimeters is x plus 1? Well, again, we use division. But first of all, we have to say that the volume is the area of the base times the height. We know the height and we know the volume. Plugging that in, we can divide both sides by x plus 1 to figure out the area of the base. And the area of the base will be the volume divided by x plus 1. And if you go ahead and do that, the remainder is 0, which means it can be divided into it evenly. So the answer is, the area of the base is x squared plus 6x plus 8. Now you can factor this further to figure out the length and width of the base. And that will be x plus 4 times x plus 2. So the possible dimensions are x plus 4 times x plus 2 times the height of x plus 1. This takes us to the remainder theorem. And the remainder theorem states that when a polynomial is divided by a binomial, like x minus a, the remainder is p divided or evaluated at a. For instance, we're going to use the remainder theorem to determine the remainder when x cubed minus 10x plus 6 is divided by x plus 4. So we say p evaluated at negative 4 is negative 4 cubed minus 10 times negative 4 plus 6, and that is going to give me negative 18. So if I took my polynomial and divided it, we should also get a remainder of negative 18. And we do. That's how that works. We'll skip the your turn. You can do that on your own. Notice that if I evaluate it at 3, I'm going to get negative 298. And if I divided it by 3, I'm going to get negative 298. So your assignment is to do page 124, numbers 1 to 12.